record the data in the table below. So after we done with the first task, we need to do the second task, which is to determine the efficiency of two stages per gear. So the setup will be the same as the first task. Then we need to set the motor speed and also the excitation current, which is the motor speed is 1520 RPM and the current is 0.32. So we need to set the speed first. 152. After that, we need to do the same thing as task 1, which is we need to balance this motor using this motor arm. Then we need to take this reading scale, which is 60.25. And then we need to multiply with 25 newton. That is for the fourth one. And then we need to use this to take the second force value, which is force 2. We need to pull it this and take the reading for the output force. After we done the experiment, we need to switch off all the current and
Hi, Assalamualaikum warahmatullahi wabarakatuh. And today I'm gonna continue the video with the part calculation, result and calculations. So for the result, we have two results, which is first increasing value of current, and we also have decreasing value of current. So for increasing value of current, we're going to use speed equal to 1500 RPM, brake serial number, which is 115990, and lever arm length equal to 100 millimeter, equal to 0.1 meter. And the formula we're going to use torque equal to force length, force multiple with length. So on the table we have current, force and torque. Which is for current, we're going to use increasing value, which is from 0 to 0.3. 0, we have a value of 0, 0.05, 0.1, 0.15, 0.2, 0.25 and 0.3. So based on the experiment, the force that we get for the first value of for the first is 100, followed by 600, 1800, 2900, 4400, 5600 and lastly 7000. And based on the calculation using the formula, the value of torque that we get for the first one is 10, followed by 60, followed by 180, followed by 290, followed by 440, followed by 560, and lastly 700. While for the decreasing value of current, we're going to use almost the same data, which is speed equal to 1500 rpm, brake serial number equal to 115990, and lever arm length equal to 100 mm equal to 0.1 meter, and the formula still using the torque equal to force multiple with length. So for this experiment, we also have like value of current, force, and torque, but in this table we're going to have a decreasing value of current, start from 0.3 to 0.25 to 0.2 to 0.15 to 0.1 to 0.05, and lastly 0. Right, so based on the experiment, the value of F that we get is 6,700, followed by 5,700, followed by 4,900, 3,300, 2,300, 1,000, and lastly 200. And based on the calculation using by this formula, the value of torque that we get first is 670, followed by 570, followed by 490, 330, 230, 100, and lastly 20. Okay, then we continue for the part calculation, which is we have two calculations. First one is efficiency of 2 stages per gear, and the next one is efficiency of worm gear. So for the first calculation, which is efficiency of 2 stages per gear, the data that we're going to use is H1 equal to 1520 rpm, current equal to 0.32 A, force 1 which is 360 Newton, and force 2 which is 7500 Newton. So we're going to find output power and input power before we get the efficiency. So the formula that we're going to use is power equal to omega m, which is equal to 2 pi f multiplied with m. When we inserted the value, it's going to be 2 pi multiplied with 25.33 multiplied with 7,500 multiplied with 0.1, we're going to get 119.36 kilowatt. And the value of F, which is 25.33, we're going to get from here, which is F equal to 1,520 divide with 60, which is we're going to get 25.33 hertz. Next, for the input power, we're going to use the same formula, and when we inserted the value, we're going to get 2 pi multiplied with 25.33 multiplied with 360 multiplied with 0.1, and we're going to get 5,729.51 watt. And we're going to change it into kilowatt, which is 5.73 kilowatt. And we're going to enter the value of input power, output power, and input power into this formula, which is efficiency equal to input power divide with efficiency equal to output power divide with input power equal to 119.36 divide with 5.73, which we're going to get 20.83. While the calculation for efficiency of worm gear is we're going same as 2 stages per gear, we're going to find out output power and input power before we insert it into this formula. So for output power, we're going to use P equal to omega m, which is equal to 2 pi f multiplied with m, and when we insert the value, it's going to be 2 pi multiple with 25.33, multiple with 6,700, multiple with 0.1, we're going to get 106.63 kilowatt. And for input power, we're going to use the same formula, which when we inserted the value is going to be 2 pi multiple with 25.33 multiple with 405 multiple with 0.1, we're going to get the value 6.446 kilowatt. And then we're going to enter both output power and input power value into this formula, which it will be 106.63 divided with 6.446, and we're going to get the efficiency equal to 16.54.
Okay, after the results and the calculations, I'm going to continue with the observations, discussion, and also the conclusion. So, for the observation, experimental evidence show that the mechanical efficiency of gear is sensitive to current within a limited range. This efficiency increase and decrease with the value of current. The experimental data and the calculated data show a statistically significant relationships, so confirming the hypothesis tested in this experiment. It has been demonstrated that when the value of current increase, the force of the lever arm and the output torque increases proportionally. Otherwise, if the value of current reduce, so with the force of the lever arm and the output torque produced. Based on the experiment, there are two transmission units in total. A spur gear with a ratio of 1 to 13.5 and a single stage worm gear. The spur gear must be mounted in straight, extended configuration, but the worm gear must be mounted in an oblique configuration. Experiments are conducted to record the brake characteristic in order to aid the modifications of the brake torque, lever arm used to measure the force. While doing the experiment, it is expected there were several factors that can affect the value of force, which is the value of current and the speed of the motor. The stability of the lever arm also can affect the final result. Okay, then for the discussion, based on the experiment that had been conducted, we can saw the usage of two different gear, which is spur gear and worm gear. Spur gear belong to the parallel shift gear group and are cylindrical gear with a tooth line which is straight and parallel to the shaft. Spur gear are the most widely used gear that can achieve high accuracy with relatively easy production process, and they can characteristic of having no load in axial direction or thrust load. A screw gear shaped out on a shaft is the worm. The mating gear is the worm wheel, and together on non-intersection shafts it called as a worm gear. Worms and worm's wheel are not limited to cylindrical shapes. There is the hourglass type, which can increase the contact ratio, but production becomes more difficult. Due to the sliding contacts of the gear surface, it is necessary to reduce friction. For this reason, generally a hard material is used for the worm and a soft material is used for the worm wheel. Even though the efficiency is low due to the sliding contact, the rotation is smooth and quiet. Also, based on the result that had been recorded, we saw that although the usage value of the current for table of increasing value of current and decreasing value of current is same, we still got different value for force and torque for both table. Since the measurement are manually by using hands, it is for sure that we can get a different value for each measurement. Other than that, the value of efficiency for both gear are quite different from where they should be. For example, spur gear should get around 94 to 90% of efficiency instead of 20.83%, while worm gear efficiency should be around 50 to 90%. And lastly, for the conclusion. For conclusion, based on the experiment that had been conducted and the result that had been obtained, we able to determine the mechanical efficiency of gears by comparing the mechanical driving and braking power for spur gear, two-stage, and worm gear. Other than that, we also able to understand a mechanism of the drive technology in mechanical engineering, encompassing of transmissions and motor related to the measurement and control technology. On this experiment also, we had to implement our knowledge based on our understanding in mechanical engineering and also analyze data that had been obtained in order to produce good technical report according to the required standard. Thank you.